Today, I'm going to walk through three important security topics in Express: protecting routes with middleware, preventing vulnerabilities through validation, and why password hashing is essential. How do you protect routes using middleware in Express? In any real application, you never want unauthenticated users accessing private or sensitive data, and even when a user is authenticated, they still shouldn't be able to access data they're not authorized to see. That's where protected routes come in. A protected route is simply a route that requires authentication before the request is allowed to continue. It acts like a security checkpoint. If the user doesn't have a valid session or token, the request stops right there. To implement this, we create authentication middleware. In my project, this lives in auth.js right here. I apply this middleware to the task routes. That means the auth middleware runs before any of the task related endpoints. If the user isn't authenticated, they never reach the logic for creating, reading, updating, or deleting tasks. So that's what this is saying. If there is no global user ID, if it's null, then they're gonna get an unauthorized status and message. And then it's connected to the app.js. In app.js, I apply this middleware to the task routes. That means the auth middleware runs before any of the task-related endpoints. This is the key difference between public and protected routes. Public routes like login or signup are open to everyone. Protected routes require authentication and act as a barrier to keep sensitive operations secure. So in this task router, it requires you to go to the task routes that I've created. But before that, if anyone goes to API tasks, they have to first go through the auth middleware and then they can get to the task router. Number two, what security vulnerabilities does data validation prevent, and how do you implement validation? So data validation is one of the simplest but most powerful security layers you can add. It filters out malicious or malformed data before it reaches your application logic or your database. Good validation helps prevent attacks like SQL injection by ensuring strings are properly formatted and not allowed to contain harmful patterns. It also blocks XSS attacks by sanitizing input so users can't inject scripts into your pages, and it protects your server from oversized or malformed requests that could crash your application. In my project, I implemented validation directly into my user schemes. My task schema and my user schema. So each field has rules like required fields, minimum lengths, maximum lengths, and type checks. These rules ensure that only clean expected data gets stored in the database. It's a simple layer, but it closes the door on a lot of common vulnerabilities. So in the task schema, it's looking for, using Joy, it's looking for a title, and then it strings the title together, trims out the spaces, and makes it between 3 and 30 characters, and makes it a required field. Is completed is also another field that Joy looks at, and it makes the default false and not null if it's blank. And then for the patch task schema, so updating tasks, it does the same thing to the title, and it also doesn't do anything to the is completed, but make sure that it's not blank. Make sure that it's at least one character and sends a message, no attributes to change were specified. In case, I don't know, somebody tries to update something but nothing changed in the title or it is completed. In the user schema, it is looking at the email and it's stringing it together, taking out all the spaces, making it all lowercase, making sure it's an email, and it's a required field, a name, same thing, stringing together, trimming off any excess spaces, min-max characters 3 to 30, makes it a required field. And then for the password, it makes it at least 8 characters, trims off any spaces, makes sure that it's like a letter or a number, and includes special characters, and makes it required. And then if somebody doesn't put in that the message they'll get back is password must be at least 8 characters long and include upper and lowercase letters, a number, and a special character. So those are the schemas. Number 3, why should you never store passwords in plain text, and what are the security principles for password hashing? Storing passwords in plain text is one of the biggest security mistakes you can make. Your application never needs to know the user's actual password. If your database were ever compromised, or even if an administrator decided to snoop, you'd be exposing users to identity theft, account takeovers, and potentially legal consequences. That's why we hash passwords. Hashing is a one-way, irreversible process that turns the password into a fixed-length digital fingerprint. You can verify a password, but you can't reverse the hash to get the original text. But hashing alone isn't enough. You also need a salt, which is a cryptographically generated random value added to each password before hashing. Every user gets a different salt. This prevents rainbow attacks, where hackers use massive pre-computed lookup tables to reverse hashes. Without the exact salt, those tables become useless. Another important principle is never invent your own cryptography. Cryptographic algorithms are created by experts, tested publicly, and analyzed for years. Rolling your own is almost guaranteed to introduce vulnerabilities. Finally, hashing is different from encryption. Hashing is a one-way process and used for integrity and verification. Encryption is two-way and used for confidentiality. You can decrypt encrypted data back to its original form. Passwords should always be hashed, never encrypted. Thank you so much.